line, which is right between those. It's the average 96 plus 64 over 2, which is 80, which will be that one there.
Got it.
Especially since this is multiple choice. No, wait, that could be wrong here. No, that's correct. That's
No,
correct. That should be
it's the right one. You're fine.
go with that one. All right.
All right, let me see.
So for this next problem here, 20 pull down distance 20, distance from its equilibrium. Okay, so we actually do have to write the equation for this one. So let's see if we can do it without the so it says an object is attached to a coiled spring is pulled down a distance of 20 centimeters from its equilibrium position and then released. Time it takes to complete one oscillation is 4 seconds. Determine the answers below. Okay. I mean, what's the risk here of like, do you only get one guess per attempt?
Pretty much, yeah. And if I get one wrong, so like how it works is it puts you at like a certain percent of like the completion of like the assignment or like of the homework. And if I get one wrong, let's say if I'm at like 50% completion, it'll push me back to like 40% or like
Okay, so
some,
you don't want to guess here, is what I'm
yeah.
hearing. Okay.
I've been scared to like do my homeworks because when I ask like when I get help from like the tutors, like sometimes they'll be wrong and then I'll be on a homework for like 30 minutes and I'm like, oh, this is just taking too long.
Yeah, because these are when you have to write the equation. One thing that we so it's starting down here 20 centimeters down from its equilibrium position. So then it comes up and does this in 4 seconds.
Mm-hmm.
And so we know at 2 seconds, I mean, it's probably we know that one point is probably here. And that's why I was guessing, like asking like, well, how so basically it's one of these answers, but we probably do need to write the equation. So this is an inverted cosine with an amplitude of 20. And then the period is 4, which is 2 pi over b. So b ends up being pi over 2. So it's pi over 2 x, something like that. So now the putting in 1.2. Like that. You got to go to your calculator and just calculate that.
Mm-hmm. 2 times 1.2.
It ends up being 6.18.
Got it. Let's see. Oh, this one I think I actually might be able to.
So upload this one. Actually, I take that back. I just had to look at it on screen. So they're giving you the temperature. They want you to find the value of T. So you're putting 22 in for T.
Mm-hmm.
History, what does she find? Yeah, so you're just putting this into your calculator.
14 pi divided by, oh shit. 14 pi divided by 12. Why do I keep doing that?
End up getting 18.
You said 18, right?
Yeah.
Alrighty. This one. Mm, 7,000 cosine 5 pi
Right.
10.
They give you an equation. They tell you that T is the number of years after 1972. So 1978 is going to be minus 1972 or 6. So you're going to put 6 in for T. Just going back to the calculator again. Round to nearest whole number. Always good to do these calculations with me just in case I make a mistake. Mistake here, 42837. It's like what I got rounded.
Yeah, that's what I got rounded to.
Okay, very good.
42837. All right. Cool. And that one. Okay, we finished that one. Let me just pull up the other one really quickly.
Okay.
0.6, 0.6. Okay, so with this one, I tried doing them, but if you can't help me with these, it's okay, because I was able to just like graph these on like Desmos, and that's pretty much how I got the answer. The issue that I was having was I didn't know how to graph it like on this system and how it does its graphs. Um, so if we can't
Yeah.
figure it out, then this one I can just save for like the tutors here, because they probably like see like this stuff more, so they might know how to do it, and then we can just try another one.
If you're willing to share your screen, I can sort of talk you through it. If you're not able to, then no, but it won't be very useful other than like you've been doing. You would graph it on Desmos and try to do it. I've helped with graphing on this system, but you'll have
Oh,
to share your screen. So let me make you co-host. Maybe we can do that if you want. Make co-host. It's up to you. If you can't share your screen, we can move on to something else.
yeah, no, it still doesn't give me the option, and I don't know why. Um, background.
If you're not using the Zoom app, it will not allow you to share your screen.
Oh, okay. Yeah, I've tried downloading the Zoom app, but I can't figure it out. Like it won't let my I don't know, I just can't find it for some reason, but I'm gonna talk to the tech people today and see if they can help me so that like next time if I make an appointment, like I don't have this problem because if I could share my screen it'd be so much easier. But yeah, it just doesn't let me for some reason.
Okay.
Alrighty. Let me just hit view answer so I can go to the next one. Next. For this homework, because I can't share my screen, we'll probably just skip this one just because all of these are like the graphing and I don't know how to do it on this system for some reason. Like I'm having a hard time with it. I don't really want to like waste time trying to figure that out today, so we'll probably just try one of the other ones instead.
Okay.
All right, let me get out of that real quick. All right, so no graphing today. We can go to fives. I think with these ones, we can probably just plug them into that app you were saying earlier, the Woof, what is it called?
It's Wolfram, but there's many other of them. Yeah, so that will be the fastest way to proceed with these. Um, Main thing here is you want to make sure that you enter them correctly. So secant pi over 4, it's actually just the reciprocal of cosine of pi over 4, which is square root of 2 over 2. The answer here is the square root of 2.
Oh, okay. All right. Cosecant of 60 degrees.
So like the Wolfram, for example, is pretty good at picking up when it's this. Now, one of the issues is that this is not rationalized.
Okay.
So it may not like that. So sometimes you got to go down to the alternate form, which is 2 root 3 over 3.
Okay. 2 square root of 3 over 3. This might be a dumb question, but how do you know by looking at it, like when it's rationalized versus when it's not? Is that like when there's like a square root like on top
On the
or?
bottom. Yeah, it's short for rationalize the denominator. So if it's in the bottom,
Got it. All right. Cotangent of pi over 3.
this one's 1 over square root of 3, which the alternate form that you want is root 3 over 3.
Oops, that's not what I wanted. Square root of. You said square root of 3 over 3, right?
Yes.
All right. All right. I'm putting them in the app too, like just so that I can like check them with you, just so I can get more like familiar with the app. But sometimes, yeah, give me like 1 over 3. Let me see this one. I think this one's just the same thing, just plugging them in. Secant 7 pi over 4.
This one's slightly different. Well, no. I apologize. No, it is the same thing. It's
Okay.
exactly the same thing. So you actually put in commas. I think it will. take them both. So square root of 2 and -1. So looks like it's the third option that you sent.
Secant 325 of the secant of a positive acute angle.
Let me go back to the other screen. Sometimes you can just type in, maybe you get what you want, but the so the 325 degrees, that's 90, 180, 270, and then 360. So it's you're going all the way around. And then how much is left over here? Well, it's 35 degrees. So the idea is that the secant of 325 is equal to the secant of 35 degrees. But then you have to decide if you can get if you need to get the sign, like if it's positive or negative. So cosine is positive there. So it is probably just the secant of 35.
Secant of 35. All right.
So this is a you can, if you kind of know how to interpret it, which I mean that's the whole, yeah, that's the whole challenge here, but it's really saying the cosine of x is 11 over 13. So what is the cotangent of x?
Would that be just 13 over 11 or?
It's not, yeah, it's not that simple. So it is this one on the right, but it's not rationalized. And this is
Okay.
part of the problem. So this becomes 11 square root of 3 over 12. 11 times the square root of 3 over 12.
And is that my answer, or do I have to actually
Yes.
do like 11 times the square root? Oh, that's just my answer itself.
Yes. Yes.
Oh, okay. So 11 times square root of 3 over 12. All right.
It's the this one, kind of like the other one here. So the secant of 135, there's 135 degrees. That's 45 degrees. So secant of 135 equals secant of 45. But since you're in the second quadrant, this is what I'm not sure of. It should be negative because secant in the first quadrant is positive. Secant in the second quadrant is negative. So these you have to put that negative sign to get the right value out. Like that's the way
So
I
do I?
read it.
Okay, no, you're fine.
I think you want to put the negative in front. You know, it's always a guess what these things actually want.
Yeah, so it's negative secant 45.
Yes.
Okay. see. Negative secant 45. Okay, yeah, it took it.
All right. This one's a little bit more difficult because of the fact that it's in radian, but still doable here.
Mm-hmm.
So the idea is that this is really pi over 2, but if you switch to the new denominator, it's 18 pi over 36. And then this is 36 pi over 36. So 25 pi over 36 is between the two of them.
Yeah.
So you take the 36 pi over 36, subtract the 25 pi over 36, 11 pi over 36. So that's your reference angle.
Mm-hmm.
So it's the secant of 11 pi over 36, but you have that same issue as the previous problem where it could be negative.
Okay. So negative secant 11 pi over 36. Alrighty. Cool. Let me get the next one. Oops, not what I wanted. M5, C5. Okay.
So the tangent of y, or the
Mm-hmm.
tangent of theta is y over x. In your problem, that's 5 over negative 12. So when you flip the signs, it's negative 5 over 12. It's like that second option there.
Oh, what the heck? That was easy. Could have done that. Negative 5 over 12. Cosine is equal to 5 over 13. And theta is in quadrant 4. Find sine.
So we got similar here. So this is back kind of to the Wolfram alpha, if it's kind of a good starting point for these types of problems. You type in the given information, cosine of x is 5 over 13, comma, and then they want sine of x and cotangent of x. And so they give you what you asked for. So sine of x is 12 over 13, which gets you down to just option B, and cotangent x is negative sorry, they're see that okay, this is one of the issues. There could be positive or negative. So in
Yeah, that's what I'm confused about. How do
yeah.
you know which one's which?
So the answer is you have to remember the convention ASTC, which tells
Mhm.
you which is positive, which is
Yeah.
negative. So in the fourth quadrant here, cosine is positive, which means that sine is negative,
Mm-hmm.
and cotangent is negative by the same
Oh,
reasoning. So the answer is they're both negative.
so would it be like
So
the third one then?
yes, that looks right to me.
Secant x is equal to 3.
So secant theta equals 3. What is sine of x? They want the other one, tangent of x. So in the fourth quadrant, sine is negative and tangent is negative. So sine is the negative 2 root 2 over 3, tangent's the negative 2 root 2. Looks like that might be the first one.
Yeah, it is.
This can kind of be done the same way. If you recognize that tangent is the y over the x, which ends up
Mm-hmm.
being 7 over negative 24. The denominators cancel, and then you can find the cosecant of x. Now, the other way to find cosecant of x is that cosecant is the reciprocal of sine, which is the y value, which is going to be 25 over 7.
Okay.
That looks to be the right answer, 25 over 7.
Do I keep the negative or no?
No negative. That's one of the issues just using these online things. Sometimes they're not exactly what you want.
Okay.
All right, so cotangent is going to be the x over the y value, but simplified. So
Mm-hmm.
it's going to be 8 over 15, 8 divided by 15.
You said it was 8 over 15 or 15 over
Yeah,
8?
8 over 15.
Thank you. This homework is so long. Given that cotangent theta is greater than 0 and cosecant.
Right, so this one goes back to the four quadrants and that ASTC thing again. So ASTC. So cotangent is positive or tangent is positive, which is in the first and the third. Cosecant is more like sine, so it's negative in the third and the fourth. So the answer is it's the third quadrant.
Third. Did you get the picture?
All right, so we got secant theta, which is really like cosine negative. So that's in the second and the third. And then sine is negative in the third and the fourth. So looks like it's again quadrant 3.
Got it. Okay. There was kind of a glare on this picture, but let me know if you can still see it.
Okay. So we'll go back to kind of Wolfram for this. Again, these can all be done by hand, but it's a little faster. So we're at cosine of x 4 square root 17 over 17. And then we want sine of x. Now in the fourth quadrant, is sine positive or negative? It's negative, so that's the one, but that's the wrong format. It's got to be rationalized. So it ends up being the root 17 comes up top, so it's negative root 17 over just 17 as the answer.
So negative square root of 17. And you said it's just over 17, not the square
Over
root of 17.
17. That's right. Same thing. In quadrant 3, they're both negative, both sine and cosine. So it's -2 square root 13 over 13. What is sine of x? So it's the -3 over square root of 13, but you have to rationalize. So that square root of 13 comes up, and then the bottom just becomes 13.
So negative 3 square root of 13 over 13.
Yes.
Negative 3. Oh, it's not 3. Negative 3 square root of 13 over 13.
All right, same thing here. So quadrant 3, both secant and cosecant will be negative. Let's see what we got here. So cotangent of x equal 12 over 5. What is secant of x and cosecant of x? And they're both negative, so secant is negative 13 over 12. Cosecant is negative 13 over 5.
Secant is negative 13 over 12,
Yeah,
and cosecant was
negative 13 over 5,
5.
which doesn't seem right, actually.
Should I wait to put it in, or should I just?
No, I'm sorry, that is right. Yeah, that is right. Sorry, they're both negative. Yeah.
Okay.
It's the same thing. So in quadrant 1, everything's positive. We love quadrant 1. 7 over 25. So we're looking for cosecant of x and cotangent of x. So you want to choose the positives there. So cosecant is positive 25 over 24.
Mm-hmm.
Cotangent is 7 over 24.
Positive 25. That's for CSC is positive 25 over 24. And cotangent 7 over 24. Cool, that one's done. Dun, 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 dun. Sorry, I'm just pulling up the other one really quickly.
Yep.
Okay, I just sent it. Simplify the following: cotangent theta, sine theta.
There it is. So this one, you go back to graphing. Let me go. Actually, we're still on that. Okay. So basically, you're just graphing the given one, seeing what it looks like. Cotangent. If I can get this to type, y equals cotangent x, sine of x. And you're like, oh, that looks a lot like a cosine of x.
Mm-hmm.
And so you graph the one that's missing there, and it will be cosine of x.
Got it.
It's the same thing. Sine y equals sine x, tangent x, and cotangent x. So that looks a lot like a sine.
Mm-hmm.
So that looks pretty good.
Alrighty.
So kind of the same deal here. Cosine, tangent, cosecant. That's a straight line, so it looks like the line y equals 1 is the answer.
Nice. Oh yes, almost done with this one. Cool.
So another one just came in. It's the same thing. Tangent x, secant x, tangent x. All right, so that looks a lot like cosecant.
Mm-hmm.
And it is
Cosecant. It's just the cosecant by itself, right? It's not the cosecant sign.
just the cosecant of x.
Got it. Perfect. MC is 5. Oh, I have a really quick question for you.
Yep.
So for December, I was looking at like the availability, like your schedule and stuff, and do you not like have anything open for December yet? Because I mean, I don't know. When I was trying to look at it, I couldn't like it wouldn't give me the option to look at December. Uh,
Yeah, I only on the website you can only book 1 week out.
oh, okay, okay,
And that's more it helps everyone so that you don't book something and then forget or I forget that hey I got a doctor's appointment or something and then so
yeah,
if you want to pre-schedule you can tell me like hey Matthew I want these days and times I can pre-book them for you
okay,
but you'll see it open up like you I mean it doesn't help but like you can book now through Thursday of
mm-hmm,
next week if you want.
okay,
And it's better to do that early than to wait because that really you'll they're really busy the next 3 weeks. And then of course
yeah,
nobody wants any help. So
mm-hmm, okay, cool, perfect, yeah. I pretty much like know my schedule is already. I just have to just be sure and just like figure out sometimes for sure. Um,
as long as you give me 24 hours notice, I'm okay if you need to move some stuff around.
okay,
It's just same day. I really can't accommodate anything like
yeah,
that at
yeah,
all. I will have no flexibility for that starting this next week.
okay,
So,
cool, alrighty. Our session is at 12:50, right?
yeah, we got a couple more minutes if you'd
Okay.
like.
Yeah, let me just try to see how many of these problems we can knock out, and then we'll be done. Oh, this is another graphing one. Okay, so maybe not that one.
It's another option is to do some in person. And I do offer discounted lessons on like Fridays and Saturdays because they're not super
Okay.
popular, but
Yeah.
it might cut into your social calendar too. So,
Yeah, no, it's okay. It's fine. I can yeah, I can see what's it called? I can see which ones I can do like for Fridays and Saturday for in person just because these graphing ones like I don't know, I don't
yeah,
know.
for
I just
for,
can't
for
figure
those
out.
I generally ask for 2 hours at a time and
Mhm.
kind of just meet somewhere locally to where I'm at within a few minutes. I'm northwestern around kind of Ina and Oracle
Okay.
area.
Got it.
Anything else you can get over here in the next couple minutes or
I just sent one right now. This will
there
probably
it
like one
is.
of the last ones.
All right. Yeah, so we're going to do this graphing again. So we got y equals 2 sine x minus 3, y equals -5. And the other thing is to really restrict the domain of this from 0 less than or equal to x less than 2 pi. You see that this actually has no solution. Wait, did I put that? I didn't put the 2 in front. Never mind. Sorry, there is a solution. 3 pi over 2.
3 pi over 2. Perfect. Can I send you one more?
Sure. All right, so we got -8 sine x -4, and then -4 square root 3 -4 So it looks like it's pi over 3 and 2 pi over 3.
Let's see. Pi over 3 and 2 pi over 3.
Yeah.
Okay. Cobains. All right.
Is that good?
Yeah, that's good.
All
So
right.
just to be clear, you said that your scheduling and stuff is about like a week